So essentially, we manage the infrastructure to get the power to your home. And if your lights are ever out, we have a wonderful staff of network operators that we can send to get your power up and running as soon as possible. Now, with net zero becoming more important, we need to make sure that customers such as yourself can connect your EVs, your heat pumps, and PVs to the network. And that's a really big responsibility we have. I think at a high level, our tech stack comprises around three things. So the first one being our cloud service provider is Microsoft Azure. We have a really great relationship with Microsoft, so a lot of our products tend to be Microsoft based. The second one is Databricks. So that's where we do a lot of the heavy lifting, number crunching, and modeling in the back end. And then the third bit is mostly Plotly Dash for our front end. Now, what this looks like in a bit more detail is we have all these various data sources from our enterprise systems being SAP for customer data, PowerOn for faults data. We also pull from third-party APIs as well as IoT sensors within the network. And all this gets ingested through Azure Data Factory. And we have a wonderful, brilliant data engineering team that manages our data lake in Azure. And they follow this medallion style architecture of cleansing the raw data at bronze stage and progressively gets cleansed to a gold stage where it can be ready for the business for consumption. And our team mainly spends their time in this processing box here, where we heavily relied on Databricks to really leverage its parallel distributed compute from PySparks to crunch billions and billions of rows of time series data from those IoT sensors. And probably something that I really enjoy is it's equipped with the open source MLOps platform, MLflow. And this really helps manage our experiments. So I no longer need to track experiments in CSVs like my dissertation. So it's great to have a nice UI to track model selection, hyperparameter tuning, and cross-validation. And you can also version control the models, and then it's ready for production use. And that output essentially is what feeds into our front end with Plotly Dash, which is also really great and user-friendly. And we can use bits like Dash Design Kit because I'm not great at HTML, so that's really helpful.
So we're a Microsoft Gold partner, and we have a great relationship with them. And so I think that can almost instinctively just encourage you to go towards Power BI. And in fairness, the business does use Power BI, and it certainly has some great applications. And I want to be clear, I'm not here to trash them in any way. But I think what we found, and the reason that we ultimately settled with Plotly as opposed to Power BI, was for a couple of reasons. One is that we really enjoy the fact that Power BI is very good at sort of taking data, visualizing it. But sometimes you want that two-way communication. You want to build more of an app as opposed to a dashboard, and Plotly really facilitates that well. The other thing is we also value the flexibility that you get with Plotly, because you can code in Python. There are a number of times I sat there with sort of Power BI, or for that matter with other visualization tools. I thought, oh God, I could do this in Python. I could do this in Python. Yet there's some kind of fundamental restriction that just prevents me from doing that. And then the other thing I would say, just from a team perspective, is we're really a team of data scientists. So we're very comfortable with Python. We enjoy using it. And so Plotly just slots in very nicely because we can actually build on top of those kind of pre-existing skills. And when you then combine that with a sort of flexibility on offer, it gives us a lot of scope to really do what we want. And then finally, and this may just be me, but I'll be honest, I can't stand data models. I hate star schemas. I just don't like it. It probably is just me, but I really enjoy the ability of just being able to kind of say, okay, here's my data. I want to write some code to do this, and this, and it just sort of gets on and does it. I don't have to worry about getting my schema in some nice format. Mm-hmm. So what we needed to do was to try and work out, in essence, how could we get other data in that would enable us to understand what consumption is like in the more rural parts of our network. So what we did is we conducted the UK's first disaggregated smart meter data trial. We spent a year working with Bays to do this. It was really heavily involved. We got roughly 120,000 smart meters worth of data. And this is really where Databricks came in, right? We needed to use their distributed compute to handle this huge volume of data. And we fed it into the model. And so two things happened. One is actually we got a slight improvement in accuracy, which was great. But the second thing, and this is the most important thing, it gave our model that kind of diversity to say, okay, we can now confidently predict secondary substation utilization, not just in urban areas, but in rural areas and in suburban areas and all across our entire network. Mm-hmm. And eventually we got to the point where the model actually was able to predict peak utilization on the remaining substations to 75 to 80% accuracy, and actually did even better on the substations we really care about, i.e. those that are loaded to at least 60%.
Our tool, alongside with his domain expertise, it adds an additional data layer onto his decision-making process. So he can take these different bits of information to essentially make an informed decision on whether they should proceed with that connection request, or if they should start thinking about procuring flex or reinforcing the network. So take this substation, for example, 0608. This one doesn't have a sensor, so it relies on our predictive model output. So if I scroll down a bit, we can see in this section, it displays the utilization predicted for the substation. In this case, it's predicting 67%. So Chris might see that and think, okay, 67%, it's not too high. Maybe we can take on this EV or other connection request. But you can also look at other data sources that we're pulling in that Rob was talking about. So one of them is our Acorn data, which is effectively our demographics data. It can tell us the different types of customers that we have in this region. One of them, seems to be like a larger population of executive wealth type customers here, so a bit more affluent, and that could possibly be indicative of an uptick in EVs since they can afford it. So Chris can take that information alongside with the other data points, and there's some other data we're pulling in. One of them being our low carbon technologies data. So you can see how many EVs we currently have on the section of the network. Currently it's at 5. So you can really pull in these different data sources along with this power flow analysis and make those decisions with data.
Sure. So the combination of all of those different data sources I mentioned, so the LV monitoring data, the smart meter data, the asset data, combined with Databricks and the nodal compute that gave us, plus Plotly, really has enabled us to realize these 4 things and realize them today. And the first is that we now have, for the first time, 100% visibility of our network. And I just cannot overstate how important that is for us. The second is that actually the business can take actions today based on sufficient accuracy. So one of the things that's really great, I mentioned earlier that figure of sort of 85% on the kind of 60% plus loaded secondary substations. That is good enough that the business can actually make a change, and indeed they are utilizing the tool that Chris talked you through. The third is that, and Chris alluded to this, but I just want to kind of reinforce the point, is that we really have clear visibility of potential future issues, which allows us to plan. So this isn't just like a kind of snapshot in time. This is what's going to happen in the next 10, 20, 30 years, running right the way up to the net zero target of 2050. And then finally, we brought all the information into one place. And this sort of a benefit may seem a little more commonplace, but actually it's still just so useful for that end user, because they no longer have to go and get data from this system over there and then that system over there. And they've got to find ways to kind of centralize it and pull it all together. Now, for the first time, they've got all of their information in a single place.